Hi, everybody. This will be a lesson for the start of our new section, 6.2, on adding and subtracting rational expressions. 6.2 is going to actually cover all operations. So first we're going to do adding and subtracting, and then in the near future we'll learn how to multiply and divide. But today's focus, as you can see by the title, is just adding and subtracting. There's some nice, clear, written out steps to start off our notes. First, we're going to factor if necessary, if we can, and cancel, which those two steps we're very familiar with because we just finished simplifying. Notice we have a two-part check process right now. It says if the denominators are the same, we're going to add or subtract the numerators and place the result over the common denominator. So if we have a common denominator, you can straight away go to performing the operation on the numerator. But if the denominators are different, we are going to have to find an LCD, which stands for lowest or least, however you like to say it. I'll use least. Least common denominator. Once we have the LCD in both fractions, we'll be able to then add and subtract, and then simplify. Notice the big bold note at the bottom. You must distribute out and combine like terms in the numerator, and then try to factor at the end. You'll see what that means once we actually start to practice. So basically, you need to simplify the top as much as possible, multiply it out. The denominator you can leave in factored form. Let's get right into some examples so we can see how all of these steps work. Our first question says 2 divided by 3x plus 5 divided by 2x. So our first step is to identify that lowest or least common denominator. And I'm going to have a practice of off to the side somewhere actually stating what it is. 3x and 2x. The smallest denominator that I can get to where that would be common would be 6x. And I can accomplish that by multiplying this fraction by 2 divided by 2. And the second fraction by 3 divided by 3. Multiplying fractions straight across, this would become 2 times 2 is 4 divided by 6x plus 5 times 3 is 15 divided by 6x. If you look, now both of my fractions, both of my rational expressions have a common denominator. And as our note said, once the denominators are the same, we're going to add or subtract the numerators. So in this case, when I look at the numerators, it's 4 plus 15, which is 19, and the denominator stays 6x. 19/6 does not reduce. I know that I am done. Number 2, we step up our game a little bit and we'll be adding and subtracting. So it's a little mix. We're adding and then subtracting 3 rational expressions. 6 divided by 5m plus 8 divided by 3m squared n minus 7 divided by mn squared. So this is where that strategy of off to the side, kind of just taking a minute to figure out what the goal is going to be. I have a 5m and a 3m here. So 5 and 3, the lowest or least common denominator for those numbers 5 and 3 is 15. Single m, 2 m's, m squared, and a single m. So I need to get to at least m squared because that is the greatest number of m's. When I look at this first denominator, there are no n values. Here there's a single n, and here there's n squared. So the fact that n squared is here, I can get this to be n squared, and I can get an n squared here, but you can never make this smaller. So at a minimum, I need n squared. So my smallest possible denominator is 15m squared n squared. So I'm going to make some multiplication decisions that will get me this in all three denominators. When I look at the first fraction, we're starting with 6 divided by 5m. So I'm going to go over here. 6 divided by 5m. I'm going to set up my parentheses. Again, this is what I have in my head as the goal. So I'm starting with a 5. To get to 15, I have to multiply by 3. For m squared, I have 1m. I need another one. And there are no n's. I need 2. So I multiply by n squared. What I multiply the denominator by, I have to multiply the top by. Plus the second piece here, 8 divided by 3m squared n. Starting with 3, I'm trying to get to 15, so I'll multiply by 5. I need m squared. Check it out. I already have m squared, so I don't need to multiply by any more m's. And then I have a single n. I'm trying to get to n squared, so I need a single n right there. So I multiply the denominator by 5n. I need to multiply the numerator by 5n. And then last but not least, our third rational expression. There's no, well, 1 is a coefficient. So I'll have to multiply by 15. There's a single m. I need 2 of them, so 15m. And then here, I already have n squared, so I'm all set. Notice how I haven't actually multiplied anything yet. I took one whole step to just establish what do I need to multiply each of these fractions by. Now let's actually do our multiplication. 6 times 3 is 18, and then n squared divided by 5 times 3 is 15. M times m is m squared, plus 8 times 5 is 40, and then n is still here, 40n, divided by 3 times 5 is 15. There's no m's in here to multiply by m squared, so m squared just comes down. N times n is n squared, minus 7 times 15. I'll give you a second to work that out for yourself. If you haven't gotten a calculator yet and you feel like you need one, grab one. Otherwise, do it off to the side. 15 times 7. 7 times 5 is 35. Carry the 3. 7 times 1 is 7. Plus 3 is 10. 105. So 105 m divided by 15. M times m is m squared, and then n squared stays. When I look, let's see what we've just accomplished with our denominators. 15 m squared n squared, 15 m squared m squared, and 15 m squared n squared. We now have our common denominator, so we can add and subtract up top. So this will become, I'm just going to read across the top, 18m n squared plus 40n minus 105m. And then in the denominator, I've got 15m squared n squared. As far as we can go. And we're done. Number 3. 3y divided by y squared plus 3y minus 10 minus 6 divided by y squared plus 3y minus 10. So before we go jumping around trying to find something, when I look, I already have common denominators. So that's really nice. So that means straight away, we can add what's up top. That'll be 3y minus 6, and the denominator is y squared plus 3y minus 10. Are we done? Well, think back to simplifying. If I ask you to simplify, up top we have a GCF, which is 3. So when I factor out a 3, that leaves behind y minus 2. And then factoring the denominator, this is a is 1, so factors of negative 10 that add to 3. That would be 5 and 2, where 2 is negative. So that will be x plus 5. Oh, excuse me, not x, y. Y plus 5, y minus 2, and ta-da, look what cancels. Y minus 2 cancels with y minus 2, leaving a final answer of 3 divided by y plus 5. So this is a great example of we are accountable for going as far as we possibly can go. Number 4, 3x plus 2 divided by 3 minus 2x minus 4x plus 1. So even though it kind of looks a little funky, I'm going to use highlighters for a second. You don't highlight what I'm about to highlight. But I first want you to realize that we've got 1, 2, 3 distinct rational expressions, or 3 distinct fractions here that we're going to work with. At first, it could maybe throw us off that 2x doesn't have a denominator, but my question to you would be, what invisible denominator is there? And let's draw it in. Well, 2x is the same as 2x divided by 1. Now that helps me to see that the denominators I'm looking at are 3, 1, and 5. So ask yourself, what's the least common denominator for 3, 1, and 5? And the answer to that, which I hope we're all saying in our brains right now, is 15. So we're going to go piece by piece and see what we have to do to get that to happen. So 3x plus 2 divided by 3 is the first piece we're looking at. Set up what I'm going to multiply by. 3 times what is 15? 5. If I multiply the denominator by 5, I have to multiply the numerator by 5. Minus, this is 2x divided by 1. To get 1 to be a 15, I have to multiply by 15. And if I multiply the denominator by 15, I have to multiply the numerator by 15. And then last but not least, I have 4x plus 1 divided by 5. 5 times what is 15? 3. And if I multiply the denominator by 3, I have to multiply the numerator by 3. Again, we have done no math here. We just set it up. And setting it up really helps your brain to see what we're about to do next. So let's get to multiplying. Really important to note that this 5 is going to be distributed to both of these terms. In effect, you could actually put this in parentheses. 5 has to be distributed to each of those pieces. So 5 times 3x is 15x. And 5 times 2 is 10. All divided by 15. Because 3 times 5 is 15. Minus 2x times 15 is 30x. And in the denominator, 1 times 15 is 15. Again, notice 4x plus 1, even though it doesn't look like it's together, it really is. So if it helps you to actually put this in parentheses so you remember that you need to distribute 3 to both of those pieces, do that. So we're going to do 3 times 4x is 12x. And then 3 times 1 is 3. In the denominator, I have 5 times 3 is 15. When I look to see the result of what we just did, and I look at my denominators, I have accomplished a common denominator of 15. And now we are going to add and subtract what's up top. So that's going to be 15x plus 10 minus 30x. Now I didn't need parentheses here because it was just a single term. But notice here, I'm subtracting this binomial. We need to make sure that we either immediately distribute the negative or use parentheses. so that you remember you need to do that. All divided by 15. So that's going to be minus 12x minus 3 when you distribute the negative. And now let's combine like terms. So I've got 15x minus 30x minus 12x. 15x minus 30x minus 12x gets you what? Combine those like terms, write it down, and we'll see if we get the same answer. So using mental math, 15 minus 30, that's negative 15, minus 12 is negative 27. And I don't want to forget x, negative 27x. 10 minus 3 is minus 7, all divided by 15. Before I commit to saying this is done, I would always want to check for a greatest common factor, GCF. When I look in the numerator, 27 and 7, there is no GCF because 7 is prime, and 7 is not a factor of 27. So that tells us we are all done. Number 5, 3 divided by x plus 2 plus 8 divided by x minus 2. Off to the side, let's make a note. What will our least or lowest common denominator be? Well, this is a new type of example because now I don't have a single number here or even just a monomial like 5x or 10y. I now have a binomial and a binomial. When that's the case, the common denominator is going to be a product of those binomials, meaning my least common denominator is going to be x plus 2 times x minus 2. That's what we're going to work towards. So let's get to it. My first fraction is 3 divided by x plus 2. So I've got the x plus 2 part. I don't have the x minus 2 part. So I want to multiply the denominator by x minus 2. If I multiply the denominator by x minus 2, I have to multiply the top, or the numerator, by x minus 2 as well. Plus 8 divided by x minus 2. Well, I've got the x minus 2 part. I don't have the x plus 2. So we'll multiply top and bottom by x plus 2. Doing the math, we're going to distribute 3 to both of these terms. So we get 3x minus 6 divided by x plus 2 times x minus 2. I literally just read that straight across. X plus 2 times x minus 2 plus, we're going to distribute 8 to both terms on the inside, 8x plus 16. And I look at my denominator, x minus 2 times x plus 2. Remember that multiplication is commutative, which means x plus 2 and then x minus 2 being second is the same as x minus 2 being first and x plus 2 being second. In other words, 2 times 3, same as 3 times 2. With multiplication, order does not matter. So when I do my little check, I have accomplished my common denominator, which means now we can just go ahead and straight up add what's up top. So if it's addition, I don't have to worry about distributing any negatives. We're going to have 3x minus 6 plus 8x plus 16, all divided by x plus 2x minus 2. Let's combine like terms. We've got 3x plus 8x. That gets us 11x. Negative 6 plus 10 is, negative 6 plus 16 is plus 10. and then x plus 2, x minus 2 is in the denominator. There is no GCF with 11 and 10. It's as far as I can go. I'm all done. Notice how from step to step we kept the fractions together. Fraction, 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 fraction. The clearer your work, the better story it tells. So please keep your fractions as fractions. Don't let numerators and denominators start floating all over the place. One more for today's notes. Number 6. We've got 4 divided by 3x to the third plus x divided by 6x to the third plus 3x squared. Interesting. So I have a monomial and then I have a binomial. There's nothing you can do to this binomial to get it to become 3x to the third. And there's nothing you can multiply 3x to the third by to somehow suddenly get addition. So looking at these as the pieces that they are, 3x to the third and then this factor, my LCD is going to just be 3x to the third times 6x to the third plus 3x squared. But then I look at that and I'm like, could I have simplified first? So take a second, look at each rational expression, each piece, each fraction, and ask yourself, using your simplifying knowledge, is there something you could have done first? Well, this fraction, nothing I can do. 4 divided by 3x to the third is just 4 divided by 3x to the third. But when I look at this denominator, I definitely have a GCF. So for a second, before we even try to do any kind of multiplying, let's leave this fraction alone. My GCF is what here? What can you factor out of this denominator? I see 6 and I see a 3, so I can factor out 3. There are there's 3 x's here, 2 here, so I can factor out a single x. And then ask yourself, what does that leave behind? Three times 2 is 6. There were 3 x's. I factored out 2 of them, leaving 1 behind. I factor out a 3x squared, that leaves plus 1. So now that we have done that, check out what can happen. This x cancels with one of those, and I get 4 divided by 3x to the third plus 1 divided by 3x times 2x plus 1. So then I look to see what I actually accomplished here, and I don't know if this actually helped me out, because when I look, my first denominator over here is 3x to the third, and I just decreased the power or the exponent down to x. So there are times where simplifying will help you, but because I have x to the third over here, that didn't actually help. So I'm going to choose to go backwards, and I'm going to stop right there to consider what I need. When I look for my least common denominator now, I had 3x to the third. Now I've got a 3x squared. So I'm short a single x. So 3x to the third. And then 2x plus 1. That is the least common denominator we are going to work towards. So let's do that. We've got 4 divided by 3x to the third. I've got the 3x to the third. I don't have that 2x plus 1 piece. For the next fraction, x divided by 3x squared. I've got the 3. I've got 2 of the x's I need. I'm missing 1. And I've got the 2x plus 1. So all I need to multiply this one by is x, and I'm in good shape. So if we had stayed with our canceled version, where don't do what I'm about to write. If I had canceled this out and this had become a 1, and then that became x, instead of multiplying by x, I would have to multiply by x squared. I'd be right back to where I was, which is why we decided to not go further with simplifying. But in another question, maybe that did help you. So realize there is an art, not a science, sometimes to realizing how far you go, and that will come with practice. Our setup is complete. Let's now do our multiplication. We're going to distribute 4 to both terms on the inside. So that becomes 4 times 2x is 8x. 4 times 1 is 4, divided by 3x to the third times 2x plus 1, plus x times x is x squared. 3x squared times x becomes 3x to the third times 2x plus 1. And when I look at my denominators, I have successfully used multiplication to obtain a common denominator, the smallest one possible. Now that I have my common denominator, we will add in the numerator. So that will be, when I see that I have addition, I don't have any negatives to worry about, I'm collectively looking at the top, and I'm going to go right to standard form. So x squared plus 8x plus 4 divided by 3x to the third times 2x plus 1. Before I commit to saying this is done, I definitely want to check to see if I can factor the numerator. This is a is 1. I ask myself, are there factors of 4 that add to 8? The answer is no, so we're done. That wraps up the first day of notes for adding and subtracting. Tomorrow's notes are numbers 7 through 13, the other half. Tonight's homework is the day 1 and 2 adding and subtracting homework. So that homework will span tonight and tomorrow night. I kind of recommend doing half tonight, half tomorrow. Nice job. Any questions on the notes or whatever questions you start on the day 1 and 2 homework worksheet, please don't hesitate to send a question on Remind. Have a good night.